So we got some sources here, and we got here destinations. Say these are the dairy products, and we are having sources which are creating the dairy. That means they are producing the milk, and these are the processing factories where we send them for packaging, etc., or whatever, to the destinations. Or there may be wholesalers who are then give to the distributors, then they give to the retailers, and so on in a chain. So this is my factory on this side. This side is a factory, and this side is where we send them. Okay, so that means this is a source which supplies. Okay, and these are the destinations where the demand emerges, right? So we have a demand and we have a supplies. The supplies is from the source, the factory side. Say this is the factory or dairy factories where the cows are, and we produce milk. So we have a supplies on this side, and the destination is where we are sending them, to transporting them to the destination. And there could be n number of destinations, and we could have an m number of sources. It's not necessarily 4 or 5, or it could be m sources, and there could be n destinations, and we are sending to each and every one, or we could send to few one. So whatever that is, our matrix we create will reflect that, and these destinations will be on this side. Okay, and the source will be on this side. Okay, say 1 2 up to the m, and destinations 1 2 up to the n. Okay, and then here is the sub source, is the factories which produce something, and they have a supply, how much they will supply. Okay, and that will be here. And same way, the row tells us about the demand. What is this destination 1? What is the demand of that? That will be on the bottom of that, because demand is on the side of destination. That means the consumer side, whosoever that is. That could be the another factory which is processing the milk. That could be the distributor who actually gets that from the factory outlet, the goods, and then give it to the wholesalers, and then that go to the retailers and all. So this could be the distributor. This could be the another factory which is using the milk and making them packaging them and processing them. Okay, making them fit for drinking and all. So this could be another. So they have their demand, how much their demand is, and that is why we have a supply should be equal to the demand. This is not realistic, because sometimes the machine is not working, so we have a demand of this much, but we are not producing that much, and sometimes demand goes low. Okay, and the supplies go increase. In that case, what's called as an unbalanced transportation problem. We will see how to fix that by adding some dummy columns and dummy rows. That will be later. Okay, right now we are only formulating the problem. Now these arcs, okay, we are showing them with the arc, that from particular source, where are we sending to the destination. Okay, these arcs, okay, we call as an arc ij. Okay, arc ij, which joins the source to the destination, and it carries two pieces of information. What information it carries? It carries what is the cost of per unit transportation, what is the cost from I to j. You are sending from I, say I is 0 here, 1 2 whatever, so I is 1, j is also here 2. Okay, so that means sending from one source, one factory number 1 to the destination second. What is the cost of that? So this arc will have two information. One is what is the cost of that, and second is the xij, what we usually say. Xij is the object which is transported, how many units you have transported, how many units you have transported from particular location to another location. And this one is the cost of the per unit. Say for example, you have sent 50 liters of milk from this location to this location. So how many units? So xij is here 50, xi to j is here 50. That means you are sending 50 liters of milk. What is the cost of per liter? Say per liter, that is cost of Cij is say 40 rupees. So 40 rupees per kg. So this is the information what an arc has. Each and every arc has two information. So that is the first is the cost from I to j, and second is the what is second? How many units you are supplying. Okay. So you have to keep that in mind when it comes to the transportation. You have two things to do. One is what is the cost, okay, and second is what is the amount to be supplied. So in nutshell, we can say A of I is what? Amount of supply. And then B of J is amount of demand. ठीक है जी? That is what is required. What you require is the demand, and what is supply. And what is the objective of the function z? It is to minimize the total transportation cost. Minimize total transportation cost. You have to minimize the total transportation cost, and which is always minimum. Okay, but we have to satisfy some constraints. And here we know there are two types of constraints. Yes, can you tell me? One is that of demand and other is that of the supplies. Okay, so if we have a kind of a problem, we just see one simple problem and understand it, then formulate it in a mathematical formula. We create a mathematical formula for that. So I am saying like this, this is the problem, and we have only 2 rows here and three rows and 2 columns. Okay, now I know each and every row has a 2 information. So each and every row, each and every block, so not row, each and every of this block actually has what? This each and every block is that arc. जो मैंने आपको ऊपर arc दिखाई, ये वाली, ये जो arc है, each and every arc कहाँ से कहाँ जा रहा है. So that is the box here. So this box is that arc that is from the which has 2 informations. Okay, so A of ij, which is the arc of ij, it is that box, and it has 2 informations. One is the Cij, that is the cost, and second is the Xij, that is the products, right? So for example, cost of this is 80, and this is say 200, this is say for example 100, this is say 300, and this is 103, and this is some 90, whatever that is. And with this we will have another information with it, that this is the Xij, because this is 1, this is 2, this is 3, and this is 1, this is 2. So how many suppliers we have? What the factory side, how many suppliers we have? Tell me, how many suppliers we have? Because this is source and this is destination. How many suppliers are there in this problem? 3. Very good. How many destinations we have? 2. And in this side we have the supply constraint. Say for example, I'm saying this should be not maximum 1000, this should be not maximum 1500. Okay, and this shouldn't be 1200. Then on this side we say this is 3000 and something, and this is 1500. So what are these constraints as? This is the demand and this is supply. Okay, this is supply and this is demand. Okay, the demand constraints on the bottom side and the supply constraints on the right side. Supply tells us about the source. The source should supply 80, say whatever that units of some product. What is that product? That is x of, this is x of 1 1, this is x of 1 2. That's what I'm saying. Each and every arc has 2 information, that is C of ij and x of ij. CFIJ is the cost, that is this 80. This is the cost per unit. Okay, this is the cost per unit of that particular product, and which is shown by X11. Okay, this is the X12, this is X21, this will be X22, this is going to be X31, X3, and here is 1. So first 3 is the source and 1 is the destination, and this will be X32. So every box has 2 information, the cost and the units, which product we are supplying. That's X11 product we are supplying, and X12 we are supplying to the from source 1 to the 2 destination, and the cost of each unit is 200. It is the cost of each unit. So 100 is the cost of each unit of 21, X21. X22 cost of each unit is 300, and so on. So what should be the objective function? To minimize the cost of transportation of this data, whatever we have. So that should be the our objective function. So what will be Xij here? How many units we are transferring from particular source to particular destination. What will be Cij here? The cost of per unit to that Xij. Okay, so how will I say the objective function here Z? Okay, the objective function Z. How will I calculate the objective function Z? And in fact, it will be min Z. Will it be min Z or max Z? Yes, can anyone tell me, will this be min Z or max Z? I'm writing min Z, or should I write max Z? It should be minimum, always minimum in transportation. So this is gonna be 80 times X11 plus 200 times X12. What do you say? This plus this plus this plus this. And how I get this? I get this, multiply the Xij with the Cij. So I'm multiplying, Anjum. I'm multiplying Xij with the Cij. That means X11 into the cost, Cij. Is it? Cij is the cost and Xij is the product. So X11 multiplied by 80 plus X12 multiplied by 200 plus X21 multiplied by 100 plus X22 multiplied by 300, or we could say just 200. This I could write here also, first 300 and then this. One second, I will write the same way. Then I write the 100 and X21 plus 300 this one, and X22 multiplied by X22 plus 103 multiplied by X31 plus 90 multiplied by X32. So जब आपको इसकी objective function निकालनी है, basically you are adding each and every box which has 2 informations, that is 80, that is your Cij and Xij. Okay, Cij is the cost, Xij is that product. Say for example, यहाँ पे आप apples बेच रहे हो और 1 kg apple का cost है 80. So जो apple बेच रहे हो कितना cost उसका है 80, sending to 11. That is shown by this 11, right? One source, one destination. So these indexes will tell us which source, which destination. First index will tell us source, second will tell us destination. And जो हमारी objective function होगी वो इन सारों का sum होगा. इन सारों का क्या होगा वो? Sum. Does it make sense? So if I write a general mathematical formula for that, how will we write? How will we write Z? So help me. If I write Z equals to summation I is equal to 1 to M, that means this much of suppliers, because M suppliers, we have M suppliers and we have N destinations. So I have to multiply them together. Okay, summation of this into this, I is equal to 1 to N. Okay, what should I sum? I should sum X of Ij multiply by C of Ij. So this is my summation formula for my objective function of transportation. Any transportation problem you have, you want to find what is its objective function, you have to add each and every box of a matrix together, and each box has two information, that is xij into cij. And xij is the product, cij is its cost. Okay, so you are multiplying that together, right? And then summing each and every box. How many times? M into n times. Because if it is 2 is here n, what is here n? N is here 2. What is here m? M is here 3. So this will be 3 into 2. That is 3 into 2 is 6. So 6 times. So that like here 1, 2, 3, 4, 5, 6 times. So I did 6 times this thing. So that's why you have to do it summation of I is equal to 1 to m into summation of I is equal to 1 into n. That means you are doing it 3 into 2 times. 3 into 2 is how many? 6 times. So what are you doing 6 times? X of ij into c of ij. You are doing this 6 times x of ij. This is x of ij, control Z, sorry, highlighter. Okay, x of ij is this into c of ij. X of ij is x11 here, c of ij is here 80. For this one, 90. What is x of ij? What is c of ij for 90? Tell me. What is firstly x of ij for 90? Yes, answer me. What is the x of ij for 90? Quickly tell me. Either put on your mic or mic मुझे headphone बाहर निकाल, कान में है ही नहीं, कोई बोल मत रहोगा कुछ. Hina Fayaz is saying 3-2. Absolutely, mashallah. What is C of ij? 90. Yes, C of ij is 90. X of ij is 3-2. So you are that is here, right? Very good. So in totality, what are you doing when you have to do the objective function of this? You are adding all the boxes together in the matrix. Okay, whatever the matrix there is, we have given. Okay, and what is each box consisting of? X of ij and c of ij. X of ij into c of. So that I did it in a short form. I say z is equal to summation I is equal to 1 to m into summation I is equal to 1 to n, because I have to do it this m into n times. And what I have to do m into n times? Summation of what? X of ij, c of ij. So I'm doing x of ij, c of ij plus next, plus next, plus next, and each and every box has two information that I'm adding together. I am doing sum. That is this shown by this sum. And how many times? Summation of I is equal to 1 to m, I is equal to 1 to n. Now this is my objective function, but this will be subject to constraints. This will be subject to, now how many constraints we have here? We will again have 3 constraints for my, this way, if I change my color, green, this way the constraint is of the supply constraint second, supply constraint third. And if I go other way around, for example this one, if I go this way around, it is a demand constraint. Okay, so for the supply constraint, if you see, I want to remove all this clutter. Okay, if I say supply constraint means this plus this should be less than or equal to 1000. Does it make sense? Because I am seeing here that I have the 1000 as a supply limit. So that means 80 x of ij 80 जो ये वाला box है plus ये वाला box है, it should be less than 1000. This will be the one constraint. Second constraint will be 100 plus this 300, it should be less than 1500. For this row, it should be less than 1200. So these are my supply constraints, 3 supply constraints, and I will have 2 demand constraints because I have 2 destinations, and demand is here 3000, 1500. So sum of this column should be less than 3000. Sum of this column should be less than 1500. So this is gonna be my what's called as a demand constraint. So I will have totality n plus m constraints. So जितने suppliers हैं और जितने आपके पास ये हैं, इतने मेरे पास constraints होंगे. क्योंकि यहाँ पे दो मेरे पास destinations हैं और 3 है मेरे पास क्या suppliers. So 3 plus 2 is 5. So I will have 5 constraints. So I will have here for z, I will have multiply. everything. 3, अगर मेरे पास 3 suppliers हैं और 2 मेरे पास destinations हैं, 3 into 2 is 6. So 6 items यहाँ पे होंगे मेरे पास Z में, ऑब्जेक्टिव फंक्शन में. लेकिन कॉन्स्टेंट्स मेरे होंगे 3 plus 2, n plus m. M is number of sources, n is number of destinations. Does it make sense what I'm saying? Let me duplicate this. So now let us go for the constraints. How many constraints I will have here for this guy? Okay. Let me lasso select it. Damn. Okay. Make it a little smaller. It's not getting properly. So just Control C. I will just simply erase this one, and because Z we got it, now we will try to build its constraints. Okay, we'll try to build its constraints. 1 second, let me remove the clutter. Okay, now okay, now if you could see, we have x11. Okay, the first constant. So if I say subject to, now पहले मैंने Z में लिखी वो क्या थी, हाँ? अब subject to, this will be, first constant will be x11 plus x12 should be less than or equal to 1000. Second will be this one, x21 plus x22 should be less than or equal to 1500. And third one will be this one, x31 plus x32 should be less than or equal to 1200. Now for these 3 I did for my supply constraints. Now with this we have a 2 more, that is of my demand constraint, that is this plus this plus this. That means x of 11 plus x of 21 plus x of 31 should be less than or equal to 3000. And for this one I have x of 12 plus x of 22 plus x of 32 should be less than or equal to 1500. Now this will be my 5 constraints. 3 of them will be the supply constraints and 2 of them will be demand constraints. Total how many constraints? Total I have m plus n constraints. So m is the number of suppliers and n is the number of destinations. So total will be m plus n, that's 3 plus 5 constraints, right? So in my Z, how many variables will be there? M into n, that is 3 into 2, that is 6. So it will be 6 items, this plus this plus this plus this, this plus this. But in that there will be xij into cij, summation of all of those. And in constraints, how many constraints I will have? M plus n, that is 3 plus 2, that is 5 constraints. 3 constraints for the supplies here and 2 constraints here for the demand, because this is the demand here, right? This is the demand here. Does it make sense what I'm doing? And in the last I say that x of ij should be greater than equal to 0. X of ij should be greater than equal to 0 for all of these. So x of 11, x of 12, x of 13, I'm writing x of ij should be greater than equal to 0. Okay. Now if I have to formulate it using the formula, so how I should say in terms of xij's for the, so in short, if I give it a new slide, if I write it in terms of summation, so I should say Z is equal to summation of I is equal to 1 to m into summation of I is equal to 1 to n. And what should I do here? I should multiply x of ij with c of ij. And then I say subject to constraints. So I will have 2 types of constraints. First will be the constraints of what? I will have constraints of supplies and constraints of demands. So if I say I is equal to 1 to n x of I j, I sum up all of those x of I j, that should be less than or equal to a of I. Similarly, if I say I is equal to 1 to m x of ij should be less than or equal to b of j. B of I, B of J, yes. I say X of ij, B of J. Now, J is equal to 1, comma 2, comma up to M. And here I will be equal to 1, okay, comma 2, comma up to N. Now, I refers to the row columns and J refers to the rows, okay, because it will be like this. You are adding this way. This is my A of I, this one, and this is here the J's. This is the B of J. This one, this one, this one, the demand. So in short, I could write it this way. And the last thing I say, X of ij should be greater than or equal to 0 for all I comma j. So in totality, I will write it like this. Now, if I have a problem, I will write this way, that what I'm saying, that the z I calculate, that I sum all the boxes I have. It's not necessary that all the boxes will be occupied, because sometimes some source is not sending to that particular destination. So for that case, you may have that box empty. Okay, if it is not sending to that, it will be empty, so it will not be added in my z. Okay, in my z it will be missing. Okay, but if it is there, it will be added, right? And so this is my z. Add all the boxes which is actually representing the arc. Every box represents an arc in my diagram, and which has a two information: what cost and which product per unit. Okay, then I have a constraints. Constraints will be on this way, and on the row wise and the column wise. The row wise constraints are the supply constraints, and the row wise column wise constraints are the demand constraints, and they should both be satisfied such that demand is equal to that supply. We will see that later, if it is feasible. Can we have a feasible solution or not? Should we do first balancing of it or not? That will be by the next lecture. We will start creating first the feasible solution. Okay, then we will try to find the optimal solution. So feasibility solution के लिए जो आपके हैं, फिर optimal solution के लिए जो मोदी वगैरह आप बता रहे थे, मोदी जी को हम बुलाएंगे solve करने के लिए. That is different thing. The first thing is the formulation of a problem. If it is a verbal information given, so you should be able to make this table, okay, where you put up all the sources on this side and all the destinations on this side, right? All the sources on this side and all the destinations on this side. Then you write here the supply constraints of each and every row, and on the bottom you write the demand constraint of each and every row, every column. Does it make sense? Any questions regarding this? Now, we should all the time know that the total demand should be equal to total supply. If it doesn't happen, we will balance it. We'll do it in the next way. That means if I total it here, you know, if I do the totality of this, if I do total this and I do total of this, it should come equal. Okay. If it is not coming equal here, then we do the balancing. That will be our next thing. Okay. Before we do feasible solution, maybe we do that first. Then we develop the feasible solution for this. Okay. And then we try to see the optimum solution from the feasible solution we built, right? So can you now, if I give you any problem, you should be able to formulate. Okay, you should be able to formulate. The formulation is in the form of a table where the destinations are on the top, the columns, and the rows are what are the rows? Yes, tell me, what are the rows? We have a very little time left. Just tell me, what are the rows here? Answer my questions. Open up the mic. Insha Koyum is saying supplies. You can open up the mic. Are the participants? 18 participants. We got only 18 participants, or the rest students? Where the rest of students gone? Okay. Firstly, if anybody has any question. So we are saying that if yes, we have a supplies. So how we will calculate the supply constraint for this? Say for example, I have the third row. Can I calculate the supply constraint using the row or a column? First tell me. Can I create a supply constraint using row or column. What is your take on that? Row. Very good. Insha Koyum is saying row. MashaAllah. Insha Koyum वही है ना जो आगे बैठती हैं उस दूसरी लड़की के साथ. Which came.
जी sir.
हाँ. Yes, yes. Nice. Hina Fayaz is also saying row. Good. So what will be the constraint? Can anyone give me the supply constraint for row number 3? Now you are saying row number 3. You can open a mic and just speak. What will be the supply constraint for row number 3? We don't say the cost, the supply constraint. In the constraint, we say like this, as you could see here, it must have been here. That's for this 1200, 1200, 1200 here, this one. X of 31 plus X of 32 should be less than equal to 1200. This is the way we write, okay? Okay. So what will be the demand constraint for the column number 1? X of 1 plus X of 2 plus X of 3 should be less than equal to 3000, right? Right. Yes, it should be less than equal to 3000. We can't write it is a 3000. Adira. We should write the proper way, the constraint. The constraint will be like this here. X of 1 plus X of 2 because this is X of 1. This one is X of 2, X is 2 and it is 1. For all of this column, the supplier is the supplier number 1, right? For all of this, supplier is 1, that is constant. Okay. If you could see here, it is 1. For this, it is 1. For this, it is 1. But okay, but the source is 1, then 2, then 3. So for the demand constraint, we have X of 1, 1, X of 2, 1, X of 3, 1, like I write here, should be less than equal to 3000. Whatever for this, X of 1, 2, X of 2, 2, and X of 3, 2 should be less than or equal to this much, whatever that is. Okay, so this is your the demand constraint. So totality, how many constraints we will have? In total, how many constraints we have? Can anyone tell me? How many constraints in total we have? You should not say 5 because in this case it is 5. In this scenario it is 5. Somebody is saying 6. Why we say 6? In this case it will be only Hinafa is saying M plus N. It is M plus N. That means how many, any number of M number of sources plus N number destinations. अगर sources मान लीजिए 10 है और destination 20 है तो total हमारे पास 30 होंगे M plus N. तो जितना M होगा plus N होगा उनको add करेंगे हम. So that will be your total constraints. How many variables will there be in my objective function? Yes. The last question. The azan going on, sallallahu. M into N. Very good. Maharaj is saying 6, but we should not say 6. We should say M into N because 6 is only for this problem. You understand, Maharaj? You are right. You're not wrong. But this 6 is only for this problem. But I'm talking about all the problems. So the number of variables in the Z will be M into N. So how the number of M is number of, what is M? Number of? Yes, what is M and what is N? M is number of. You can open up the mic or say and or write it here. M is number of, and what is N number of? What do you mean N and what is M? M is number of, yes, source or suppliers, right? And N is the number of destination. Sources and demand. No, demand, destinations. Destinations, yeah. Demand is of destination. That is this thing, 1000 here. But we are talking about N is the number of destinations. Yes, you're right. Okay, then hopefully we have cleared the formulation of transportation problem. Everybody will be a better position to formulate a transportation problem now. I hope so. I will give you some examples also in the notes. You may be you see those examples, and also you should work from of your own onto the examples of formulating from verbal problem into the formulation, mathematical formulation. Okay. Okay then. Allah Hafiz.